Listen up. Today's lesson is challenging. So I need you to close your face and let me talk. Shh. Antoine, are you ready? Okay. Shh. We're doing sequences. We're doing sequences. Your notes start on page 10.
Are you serious? How do you do that?
Oh, it's taking my notes to the wrong thing. You were not looking at me. Be honest. Shh. Okay, here we go. So a sequence is a function, which means that we can write an equation for it. Ma'am, I already did. A sequence is a function that means that we can write an equation for it. The important thing is that the domain, remember the domain is the numbers that you input into the sequence, like the inputs. The domain is the set of natural numbers. So the domain is always going to be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going on forever. Never zeros, never negatives, never fractions or decimals. Okay. A sequence is typically shown as a list of numbers. We call those numbers terms or elements. And sometimes writing the notation for a sequence, like the equation for that, can kind of be tricky. Okay. So the first thing that we're going to do is just look at these numbers kind of and figure out what it's saying. So our first example has the sequence with numbers 4, 8, 16, 32, 64, 128. Sir, you know what? You know what the function is. What are we doing? We're doubling everything, okay? We are doubling everything. So we'll come up for that equation in a minute. Let's talk about what this is asking for right here. So this is like the notation that we use for sequences is weird. So what is it saying right here? A represents the sequence. Doesn't this kind of look like f of x? So, but it's a of 3. So it's function notation. And this is just saying what is the third term or element in our sequence. What is the third term in our sequence? Yeah. So a of 3 equals 16. Okay. That's all right. So this one, question B says, hey, find the what term? And add it to the, yeah, what is the first term, Brody? And what is the seventh term? So this equals 260. Does that make sense? Okay. So example C looks different than example A or B. This little guy right here is not an exponent. This is called subscript. That when you have what looks like an exponent, but it's on the bottom side of the number, it's called the subscript, but it means the same thing. This is asking what is the second term. So 8. So A subscript 2 equals 8. And that's how we say it. We don't say A squared. We say A subscript 2. Do I need to write that maybe? A subscript. I spell it wrong all the time. Subscript 2 equals 8. That way you know how to say it. God bless you. So let's look at example D. Ooh. So what is that saying? So it's saying the first term, and we have to square it. You're exactly right, Tessa. This says take the first term and square it. So that means the first term is 4, and I have to square it. 4 squared is, what'd you say, Kane? 16. Okay. Dakota, what does example E say to do? a subscript 5 minus a subscript 4. So what does that mean? It really, like, what is it saying in your brain? What are you thinking? Find the what? What number? What did I just write up there? The fifth term minus the what? Can you read what I wrote up there? Okay, it says find the fifth term minus the fourth term. So what is the fifth? So 64 minus what?
32.
Okay, so what is 64 minus 32? Yes.
I knew that, but like you made it weird.
I don't know how I made it weird. I think you made it weird. Yeah.
Like 4 and 5. Like I knew it was 32 and 64, but I thought I was wrong.
Okay. Why did you think you were wrong?
So I wasn't paying attention.
Yeah, no kidding. Okay, listen up. So F. So for F, it's not telling us what the nth term is that we're trying to find. It just tells us what the solution is, like what that nth term is. So what term is represented by the number 128? The sixth term. So a to the sixth equals 128. That just means that n equals 6. Does everybody see how we figured that out? Okay, yeah, I'm going to show you. Watch. So this is saying right here, this is saying what number of term equals 128. So let's count them. First, second, third, fourth, fifth, sixth. Oh, the sixth term is 128. Does that make sense now? Good. Yeah, you're welcome. Okay. So sequences are functions. Oh, I hate it when I do that. Sequences are functions, and remember that we can represent a function with an equation, right? So the only difference is like just remember that the output for your function is it's not going to be a line. We can't connect it because remember that our inputs are whole natural numbers, right? Okay. So we're going to look at this sequence. A to the n equals 2n plus 1. And we're going to write out the first 5 elements, meaning this is what it's asking. What is a to the 1? What is a to the 2? What is a to the 3? What is a to the 4? And what is a to the 5? So I'm going to wait for everybody to write that down. So we're taking that a to the n equation, which is just a function that just says, hey, whatever number you substitute in, you replace the n with, right? So a to the 1 just says get rid of the n and replace it with a 1. So God bless you. So a to the 1 is the same thing as 2 times 1 because that was an n plus 1. Well, what is 2 times 1? 2. And what is 2 plus 1? Okay. So I'm going to write it all the way over here. So a to the 1 equals 3. Got it. That makes sense to me. So let's look at what a to the 2 is. Well, that says take your formula right here. 2 times 2 plus 1. Well, 2 times 2 is plus 1 is. So a to the 2 equals 5. And a to the 3 is, well, 2 times 3 plus 1, which is the same thing as 6 plus 1 or 7. So a to the 3 equals 7. Are you guys noticing something? Why is it adding 2 each time? Yeah, but what does that number represent? Think about what you know from other equations that you've seen. Like y equals, what were you going to say, Brody?
Is that the intercept? The y-intercept?
It's not the y-intercept. It's the slope. Yeah, and the slope is how much you change your output, how much your output changes each time. And our slope is 2. That's why our output is increasing by 2 each time. So do I have to show the math the rest of the way, or can I just say that a to the 4 is what? And a to the 5 is 11. Are you guys all comfortable with me doing that? Okay. Does that make sense?
Yes.
So that's why we're doing sequences now, because, well, you know a lot about equations now. So it just kind of makes sense to throw it in there. So the next thing that we have to do is we have to graph these. So these are the numbers 1, 2, 3, 4, 5. And then this is like, 1, 2, 3. And I'm not going to keep numbering it. So this says that when a is 1, a to the n is, when n is 1, a to the n is 3. When n is 2, a to the n is 5. And can't I just go up 2 over 1 each time? Because that's what my slope is. Are you guys okay with that? Up 2 over 1, up 2 over 1, up 2 over 1. Are we going to connect these with a line? No, because these are whole numbers. Actually, they're natural numbers. So are we going to figure out what happens when n is 0? No, because we don't start with 0. We always start with 1. Okay? Does that make sense?
Yes.
Okay. So it says, why shouldn't we connect the points plotted as like a continuous straight line? Well, that's because our input values, which we know the math term for that is the domain, but it's easier to think of them as input values. They are natural numbers. And I'm going to put in parentheses what that means. That means 1, 2, 3, 4, and then I'm just going to kind of ... Okay. Does not include 0, does not include negative numbers, no fractions, no decimals. Natural numbers are actually called the counting numbers. Do you guys remember when I told you that at the beginning of the year? Do you know why they're called the counting numbers?
No.
When you were little, and you learned how to count, did your parents teach you 0?
No.
No, they did not. No child has an understanding of 0. They started you with 1. 1, you started counting things like blocks or toys on the floor. 1, 2, 3. Okay, listen. So what is the 21st term of the sequence? What is that asking me for? Yeah, to plug 21 into the formula. Good job. So a to the 21st is 2 times 21 plus 1. So a to the 21st is 43. Thoughts? Okay. Who said their brain hurts? Well, your face is killing me. Teasing. Gavin. Okay. Mr. Kane. Yes, I can. You're welcome. Okay, so this next part, listen, this next part is how you come up with your equation. It's how you come up with your equation, okay? So this word recursive, I just want to explain that to you. It sounds like a horrible word. It is a horrible word. I don't like it either. However, here's what recursive means. When we talk about a recursive formula, because that's what these are called, we just want to know, like, the formula is derived because it depends on what happens to the term before it. Like when we looked at that sequence 4, 8, 16, the 8 was determined by what came before it, 4 times 2. The 16 was determined by what came before it, 8 times 2. So it's called recursive. So I'm going to write a sequence up here. 1, 2, 4, 8, 16. So I can't figure out this term unless I know what the rule is. And I'm multiplying by 2, right? So I know that the first term is 1. And if I multiply it by 2, then I get the second term. I can't figure out the third term until I know the second term. And I take that and multiply it by 2. So the next term depends on what the one before it was. It like builds. Okay. So there's this horrible thing right here that I know is making you nervous, but let's kind of break this up. This says the first term is 7. First term is 7. That's all that's saying. It's saying the first element of my sequence is 7. Okay. So this says, well, what is b to the I, which is like saying the ith term or the nth term. They use the number or the letter I to represent an integer. That's why they use I. Okay. They want you to use a whole number, just so you know. Okay. So it says, well, hey, all you do is take the term before it. That's what I minus 1 is, and add 4. So I'm going to write here that the first term is 7. So if I want to find the second term, I'm going to use this formula that says b to the I while I'm looking for the second term. So b to the 2 equals, let me put a colon there. So I'm looking for the second term, which is b to the 2. That's where we are right here, b to the 2. Well, b to the 2 equals b to the 2 minus 1, which is what? What's 2 minus 1? What term is that? Okay. I'm going to stop right here. Go ahead. What do you think, Gavin? Okay. Here's what this is saying. This is my first term. B to the 1. I want to find the second term. B to the 2. I know that b to the 1 is 7 because it tells me that right here. Hang on a second. So here's what it says to do. To find b to the 2, I have to use this formula right here. So it says take b to the 2 minus 1, and we're going to add 4 to it. Okay? So what is b to the 2 minus 1? Hang on. No. What is 2 minus 1? So this is what this is saying. This is saying, so b to the 1 plus 4. But what is b to the 1? It would be 7 plus 4, which is 11. Okay, hang on. Let's do it again. Let's find b to the 3. So that's the third term. Third term. Listen, which is b to 3. I'm going to erase what I wrote up here for this. Like, I feel like you guys can't see the equation. Whoops, that just scribbled it out. Okay. We are using this right here. This is the recursive formula. Okay. So that formula is saying b to the 3. So I'm going to replace this with a 3. So you take the third term equals b to the 3 minus 1 plus 4. But what is 3 minus 1? So it really says take b to the 2, b to the second, be the subscript of 2, and add 4 to that. But what is the second term? 11 plus 4, which is? So every time you'll be adding 4. That's what this is saying. Every time you're going to add 4. Yeah, let's do it again. You just have to know how to work the formula. You have to know how to work the formula. So b to the 4th. Well, that says take b to the 4 minus 1 and add 4 to it. But the subscript of 4 minus 1 is 3 and add 4 to it. But the third term is 15, and 15 plus 4 is 19. Do you understand it now? So it says write out the first 4 terms. So the first 4 terms, well, that's 7, 11, 15, and 19. It's not hard. It's just weird to try and understand that recursive formula. That's the hard part. You could look at that sequence of numbers 7, 11, 15, 19 and know that you're adding 4 each time. It's just kind of picking apart that formula that makes it tough.
So basically,
That's right. Go ahead.
basically it's like B in the term equals B in the term plus 4.
Yes, that's exactly what it is. So listen to this. One of the most famous formulas or recursive formulas is the Fibonacci sequence. Have you guys ever seen it? I'm going to tell you. Hey, listen. It's the Fibonacci sequence. Okay. So let's just break this apart. This says that the first term is what? First term equals 1. What does it say the second term is? Second term equals 1. What does this say to do? Because that's the recursive formula. Let's say what this says to do in our own words. Okay. So we know what the first term and the second term is, right? So I have to get rid of that B1, 2 on the board. It's driving me crazy. We know what the first and the second term are because it's given to us. So let's start with the third term, a to the 3, which means that n is going to be 3, and we're going to plug it into that formula.
Who's in 3?
Okay, because we're going to the third term. N is just any term in your sequence. Because we already know what the first and the second term are. Okay, so now we're at A3. So the third term, because we know what A1 is and we know what A2 is. So we're going to take A to the 3. That means N is going to be 3, and we're plugging it into that formula. So it's, yes. It says recursive form. That's all right. So this formula says A to the 3 is A to the first term. What do we do with it? Well, we take 3 minus 1. And to that, we add the second term, which is A to the 3 minus 2. So let's simplify that. What is A to the 3 minus 1 really talking about? A to the 2, which is the same thing as the second term. And what is A to the 3 minus 2 talking about? A to the 1, which is the first term. So here's what this is saying to you. It's saying to find the next term. Whoops, I'm missing a T there. To find the next term, you add the previous. Previous means before 2 terms. So let's write out what we know. Fibonacci sequence starts with 1 and a 1. We just figured out that A to the 3 is what? 2. How did you do that? Because 1 plus 1 is? Okay. So the next term, to get to the next term, we have to take the 2 numbers before it and add them together. What's the next term? What's 2 plus 1? Okay. To find the next term, we take the 2 terms before that and add it together. So what's the next term? To find the next term, we take the 2 numbers before that. Keep going. And 21 and 34 and ... Do you guys see what we're doing? So let me kind of try to color it in. We added these 2. Yeah, that's the hard part, is figuring out the formula. Okay. Okay. The formula is the hardest part to figure out. And so I just want to, Dakota, I'm sitting right behind you. You're a heavy sizer, probably going to be all up in the video. So look, we know what A to the 1 is. We know what A to the 2 is. So the next term we have to talk about is A to the 3. This says let N equal 3. and you do 3 minus 1 and 3 minus 2. That's all we did. 3 minus 1 is a to the second, which is 1. And 3 minus 2 is a to the first, which is also 1. And then you're going to keep going. So if I wanted to find a to the fourth, I would plug in a 4 here. Well, 4 minus 1 is 3, and 4 minus 2 is 2. So that says add the third and the second term together. Are you guys understanding how that formula works? Okay, so I think that's the only hard part is figuring out the formula. Okay. It is our last page of notes. Okay. Kirk is trying to train for a marathon. His first month, he runs 5 miles. So listen, this is a to the 1. He's running 5 miles. He adds an additional 3 miles each month. What's that going to look like? Yeah. We have to give the recursive definition, meaning we have to make the formula for this. Okay, so what's the initial value? We always have to start with a to the 1. What's the initial value? So a to the 1 equals 5. You always have to start with that, okay? So a to the 2 is 5 plus 3, which is 8. So now we have to come up with the recursive formula, which is a to the m. That's the formula that we're writing. So what did we do? We took the number before, which is a to the m minus 1, right? And what do we do to it? We added 3. So let's try and see if this is going to work, because I heard Daniel have an aha. So Daniel, if I wanted to use the formula that you just wrote, I wanted to use this right here. This says that a to the 5 can be found by taking a to the 5 minus 1 and adding 3 to it. But what is a to the 5 minus 1? Well, that's a to the 4. And if I look at the fourth term, a to the 4 is actually 14 plus 3 is a to the 5. So I believe that the recursive formula part is tough, but that's the only tough part about this. So remember that the way to write the formula is to find the term you're talking about right now. You always have to figure out what happened to the one before it. That term minus 1. And then you figure out, oh, you're adding 3. So that term minus 1 plus 3. Or that term minus 1 plus 5. Or that term minus 1 times 2. Okay? Does that make sense?
Yes.
The last thing that we have to do is graph those. Can you guys just plot those points that we just graphed? The table. So when when m is 1, we are at 5. So that's like right here. When m is 2, we are at 8. When m is 3, we are at 11. When m is 4, we are at 14. What is this? 2, 10, 12, 14, sorry. And when m is 5, we are at 17. That's what we just did. Okay, ma'am? Yes, you may. Okay, so your homework, no, you can't start the homework because I'm going to give you your quiz. But your homework is this next page, front and back, pages 12 and 13. Pages 12 and 13, okay?